Okay, now suppose we have a matrix A, 3 by 3 matrix, and we know the Cholesky factorization. A equal R transpose R, and R is given by this matrix. And now the question is, how do we make use of the Cholesky factorization to find A inverse? Okay, so remember A inverse is a matrix when a matrix X, when you multiply AX, then you got identity. Okay, then X is just the inverse of the matrix A. And now I want to make use of the Cholesky factorization. So instead of writing AX equal identity, I write R transpose R. X is identity. And now I will solve this one by 2 steps. So I solve R transpose capital Y equal identity. Okay, I got step 1, and then step 2 that I solve Rx equal Y. Then I recover the inverse of the matrix. So now, how do I do it? Step by step. So in order to solve step 1, I solve R transpose. So what is R transpose Y equal identity? So this is a matrix R, yeah? And I write out R transpose. So I have root 2 minus 1 over root 2, and then root 2. And then 0, 1 over root 2, 0, and then 0, 0, 1. And now the matrix Y, I just write down everything entries by entry. So Y11, Y12, Y13, Y21, Y22, Y23, Y31, Y32, Y33. Then I set it equal identity. So the matrix identity matrix is 1, 1, 1 on the diagonal, and 0 off the diagonals. Okay, so now we have the equation R transpose times the matrix Y equal identity matrix. So now, how do I solve it? So first, I just take the first column of the matrix Y, and I multiply it out. Then I have square root 2 Y11 equal 1. Yeah, so the first column equal the first column here. Then the second row with the first column here. So give me minus 1 over root 2 Y11 plus 1 over root 2 Y21 plus 0 equals 0. And then the last row is square root 2 Y11 plus 0 here plus Y31 equals 0 here. So now we will solve this system by forward substitution. So the first equation gives me Y11 is 1 over root 2. And the second equation gives me, so minus 1 over square root 2 times 1 over root 2 gives me minus 1. Sorry, minus 1/2, yeah. So minus 1/2, Y11 is 1 over square root 2, yeah. So then plus 1 over root 2 Y21 equals 0. And the last one is Y11 is 1 over root 2. Cancel with root 2 here, give me 1 plus Y31 equals 0. So now Y11 is 1 over root 2. So now I have Y21 equal 1/2. Yeah, move this one to the right. Multiply by root 2. So it will be 1 over root 2. And then the last one gives me Y31 is minus 1. So I can fill up the first column of the matrix Y. So Y11 is 1 over root 2. And then Y21 is 1 over root 2. And Y31 is minus 1. And you can use the same method. So I'm not going to repeat here, but you can use the same method for another 2 columns in order to find out all the other entries of the matrix Y. So I just write down, so here will be 0, square root 2, 0, and this one is 0, 0, and 1. And you can verify that, if you multiply this matrix with this matrix, you get identity matrix. For example, the first entries, so you got 1 here, then 0, 0, so give you 1. And this one, so you got minus a half, plus a half, and 0 give you 0, and so on. So you should get the matrix Y given like this. Okay, so now we finished the first step, and now we have to do the second step. Now I want to solve Rx equal Y, and remember the matrix R is given here. So the matrix R is square root 2, 0, 0, and minus 1 over root 2, 1 over root 2, 0, and root 2, 0, 1. So this is a matrix R. And the matrix X, I do not know it, so I just put in X11, X12, X13, X21, X22, X23, X31, X32, X33. And then the matrix Y, I found it out in the previous question. So it will be 1 over root 2, 1 over root 2, and minus 1, 0, square root 2, 0, 0, 0, 1. So now, as before, I'm not going to solve the whole thing at the same time, but I just take the first column, I multiplied it out. So I have root 2 times X11 minus 1 over root 2, X21, and then plus root 2 X31 equal the first entries here, so 1 over root 2. And then after that I take the second row, so 0 here, then 1/2, 1 over root 2 times X21 plus 0 equal 1 over root 2. And the last one is 0, 0, so X31 is equal the last column, so minus 1. So now I have the system of 3 equations. And you see that I can do the backward substitution. So I have X31 already. So then I have X21 as well. So X21 is just equal square root 2 over root 2, where it just equal 1. Yeah. And now after that, I can plug it in here. Then I have, so right now I have square root 2 X11. Now I have minus 1 over root 2. So X21 is just equal 1. I leave it here. And now plus square root 2 times X31. So X31 is minus 1. So I just have minus here equal 1 over root 2. Okay. And so now I just multiply everything by root 2. Then I have 2x11 minus, multiply by root 2, so I get minus 1 minus 2 equal 1. Yeah, so then give me 2x11. So this one gives you minus 3, so minus 3, so plus 3. So plus 3 is 4. So x11 is just equal to 2. So you see, now I fill up the first column of the matrix X. And if I put it in, then this one will be 2. And x21 is 1. x31 is minus 1. So using similar method, you can fill in all the entries of the matrix X. Yeah. So the other entries are 1, 2, 0, and minus 1, 0, 1. So you can verify that this matrix is A inverse. And this is how you use the Cholesky factorization to find A inverse. You see, I mean, this equation, you can use forward substitution, and this equation you can use backward substitution, and it can be programmed very easily using MATLAB or other languages. So you see, that is the advantage of Cholesky factorization when you try to use it to find A inverse.